Be methodical. Be methodical. Start with 1 times 432. It's even, so 2 times. Half of this is going to be 216. Go to 3, and you have the you can test the 3. And again, you're probably going to use your calculator. But 3, 2 plus 1 is 3, 3 plus 6 is 9. 3 is going to go into it. So it's going to be 3 times. So this is going to be 432. Technically, you're doing this right here. 432 divided by 3 is going to be 144. All right. And then 4. So you're looking at 32. 4 goes into 32. Which means if 4 works, 4 is equal to 2 times 2. So it really is, kind of put things together. I would just need to divide this by another 2, and that would give me a 4. So don't think so hard that you have to go back to this. You can just divide by 2, and you get 108. So 4 times 108. Let me put it 4 times 108. That's what I'm pulling from. If you didn't use a calculator. Or you go up here and go, all right, 432 divided by 4 times 104. You see the pattern that you should be getting. Over here on the left-hand side, the numbers are doing what? The left-hand side. What do they do? Yeah, they're increasing. They're getting big. And the numbers on the right are getting small. They're decreasing. Not by the same amount, but they're decreasing. And 5 is not going to work because it doesn't end in a 5 or 0. But will 6 work? So you could, again, divide by 6. But again, 6 is just 2 times 3. So I can either go this 2 times a 3, but I would have to divide this by 3 and figure out divide by 3 what the answer is going to be. Or I could take that 3 right here. 3 times 144 is 432. But then I can say, all right, this is 3 times 2, factor that into 2 times 72. So it's 6 times 72. Or you go back to the 432 divided by 6. So 6 times 72, and again, in there, really small. 7. Well, if 7 were going to work, 72 or 6, I'd have to be able to divide by 7. I'm not even going to bother checking the big number because this 7 would have to come out of these 2 as well. Any factor you think is going to work has to come out of the factors you have because you're continuing with the factor. If it's a factor, it would divide any of the factors. So 7 is 8. 8 goes into 72. So 8 works. So where am I going to get 8 from? 4 times 2. So I have 4 times 108. To make an 8, I would go 4 times 2. So that's 2 times 54. So that's where that 2 is coming from. So 8 times 54. Or just go 432 divided by 8 and each one. 9. Well, since 3 works, 9 is going to work, not necessarily. But because the digits add up to 4 plus 3 is 7, 7 plus 2 is 9. Since the digits add up to a number that 9 will go into, we can divide by 9. So 9 does work. So you can just divide the number by 9, or Here's where the 9 will come from. You got a 3 times a 144. So to make a 9, you just factor out 3. So 144 divided by 3 is going to be 3 times 42. No, 46. What is 3 times, well, shoot, 36. No. Nothing. Yeah, no. 120. 24 more. 48. Hello. But 9 times 48. Some of what I'm doing over here is not making sense. Which is a great move. Talking heads, stop making sense. 1983, I think. So that was, you were born? 83? No? Okay. Doesn't end in a 0, so 10 doesn't work. If it's an 11, 11 would divide by 2, and it don't. A 12. Well, we can make a 12 if I have a 6, and then can I take another 2 out of this? 6 times 2, can I take a 2 out of it? Can I divide 72 by 2? Yeah. Or 4 times 3. 1 plus 0 plus 8 is 9. I can divide this by 3. So 4 times 3, I can factor out a 3 and get 12. 12 is going to work. And I'm just checking it before I actually do it. Let me use a 6 times 72. I want 12. 6 times 2. So that factors into 2 times 36. So it's 12 times 36. We're supposed to get 20. I have 1, 2, 3, 4, 5, 6, 7, 8. But that means 8, 9, 10, 11, 12, 13, 14, 15, 16. And one more, two more pairs. So 12, 13. Well, 13 is not going in. You don't know it. 14. If it was 14, I need a 7. If it's 14, that's 2 times 2. 15 ends in a 5, so it ain't 15. 16. Well, 8 is half of 16. If I can take another 2 out of 54, I can make a 16. Can I take it back to 2 out of 50? Yeah. So that would be 8 times 54. So 8 times 2 times 27. 16 times 27. $17, no. 18, no. Because it's 18, maybe 18. Can I factor a 2 out of this? Because 2 times 9 will be 18. So I can factor a 2 out of it. 9 times 48. Because if it's divisible by 18, 18 means it would have to be divisible by a 2 and a 9. This is even, and 9 goes into it evenly. So this is a 9, and that's a 2 times a 24. That's 18 times 24. $19 is a no. The next one is 20. 20 ends in a 0. That doesn't end. 21 has a 7 in it. It just doesn't have a 7. 22 has an 11 in it. That doesn't have an 11. 23 is prime. 23 is not going in there. And then we get to 24, which it repeats. Now it repeats all the pairs. So that's the last pair of the factors. So then are when we list the answers, just be neat. You go 1 and 2 and 3 and 4 and 6 and 8 and 9 and 12 and 16 and 18 and 24 and 27 and 36, 48, 54, 72, 108, 144, 216, and 432. You should end up with an even number because they all came from factor pair. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So if you end up with an odd, not wrong, this one. But your work will help. You would have to listen like this. You know what? Yeah. One of the things that you have to realize that when if you are going into the teaching profession, you have to realize you are going to be responsible for communicating answers and expressions and ideas to other people that don't understand what the heck is going on. I know mine isn't that great right now, but I'll tell you, I can barely hold my head. Neck is hurt. I have an excuse, which really, it doesn't matter. I should try and do better. All right, on the second problem, it's going to be a little bit like this. Oh, we're into the 441 after we leave. Since it was already. Two adult siblings are not always able to visit home at the same time because of their schedules. One is able to visit 20 days, but the other is able to visit 15. During the course of the year, how many times will both siblings be visited every day? I think we did this already in class. So how many times will we be able to visit? So we're basically looking for the common multiples of 20 and 15, all the way from 1 day to 365. So from 1 all the way to 365. The first time that 20 and 15 are going to come in common. So we got 1, 20, 40, 60, 80, 100. And you can count all the days from 1 to 365 by 20s. And then 1, then you have 15, 30, 45, 60. Okay, we have a winner. And then 75, and then 90, and then 105, and then 120. And then you have a winner. Or you just list the multiples instead of thinking about that. Your factors for 20, 4 times 5 times 4 times 5 20. And so 2 times 2 times 5. And then for 15 is 3 times 5. So the days they're able to meet has to be divisible by a 4, has to be divisible by a 3, and it has to be divisible by a 5. If they're going to meet, the days they're going to be able to meet has to be divisible by 60. Because that's the only number or the first multiple that 15 and 20 will go into. So they can meet on the 60th day, then the 120, then the 108, then the 240th day, and then the 300th day, and then day 360. That's 6 days in accounting. All about the factors. if I'm the guy that meets every 15 days, then I can only meet if it's divisible by 3 and above. And if you're the guy that can meet on the days of 20, it has to be divisible by 4 and above. So it has to be divisible by 3, 4, and 5, which is 60. So only the days that are divisible by 60, which is 60, 120, 180, 140, 300, and 360. That's 60. In this example that I left with for 441, one times 441 does 2 work. No, it was odd. Which is, oh, that's kind of nice because now you don't have to worry about all the other evens. 3, 4 plus 4 is 8, 8 plus 1 is 9, 3 goes into it. So 3 times 441 divided by 3. 3 goes into the 100th place 1 time. So 100 times 3 is 300. We're left with 141. In the 10th place, we're looking at 14. So 4 times 3 is 12. In the 10th place, it's 120. They subtract, and we get 21. 3 goes into 21 in the 1's place, 7 happens. So this is 3 times 147. And it is also tempting to say, okay, I guess that must be it. That's why you have the tests for divisibility. 1 plus 4 plus 7, that's 5, plus 7 is 12. 3 still goes into it. So you can factor another 3. So this is going to be 3 times 147. That's going to be 3 times the 3 times a 49. Because 3 times 50 is a 150, and 147 is one of those 3s less than a 150. So instead of 3 times 50, it's 3 times 49. So 9 times 3. So is there anything else you can break down? 4 is not going to work. 5 is not going to work. 6 is not going to work. 7. Let's test 7. If we do that little test that I showed you, I know you're going to use your calculator. We take this digit, and then we take that 1, and what do? We double it, and we get 2, and then we subtract it from the other 2 numbers. 44 minus 2 is 42. Is this number divisible by 7? Yes. So the deal is, I don't know what 441 is. So I take the last digit, I double it, and then I subtract it from the remaining digit. If I get a number that I know is divisible by 7, then that whole number is going to be divisible by 7. That's what I know how to start. So 441, you did it the long way. 7 would go into that in the 10th place 6 times. So we get 7 is 42. And we subtract and we get 21. Well, 7 times over 3 times. 7 times 6 plus 3. So you know what? I got ahead of myself. I should have done the 3. We should have done the 7 before the 9. 7 times 6. That false. I went right over the 7, went straight to the 9 because I knew it was not, I knew 9 was. So then 9, 10 doesn't work. 11's not going to work. 12's not going to work. 13, nope. 13 is going to work. 14, needed. 15 doesn't have 5, 16, needed. 17, that's a prime, we're going to 1. 18 is even. 19 doesn't go to either one. 20, no. 21. It's divisible by 3 and 7, so 21 would work. In fact, 441 is the square of 21. 21 goes into 41 2 times in the tens place, and you get 42. When you subtract, you get 21. 21 goes into 21 one time. So it's 21 times 21. And you're done. So that will happen at 1 o'clock. That's when that quiz will be. Just as we were getting into the visibility by 10. So just a quick where we are. This support class is not to lecture on the 12 o'clock stuff. What I'm going to talk about now is where we're going to be at 12 o'clock. What we need to make sure we know. So we have our divisibility test. 1, 2, 3, 4, 5, 6. A nice little thing of 7 if you want to use it. 8. Technically, if you know 4, you can divide by 2 again. That will give you 8. But the rule for 8, because it's not here in the notes, if the last 3 digits are divisible by an 8, you can divide the whole thing by 8. So you have to either know the last 3 digits by heart, know that that number is divisible by 8, or you have to check the last 3 digits. Sometimes it's just easier to whittle it down. 9, with all the digits add up to a number that you divide by 9, you can divide the whole thing by. And then 10 is 0. There's nice rules for 11, just like the 7. For 12, 4 and 3 work, 12 would work. For 15, if 3 and 5 work, 15 would work. For something like an 18, 2 and 9. 20, it ends in a 0 and a 7. You divide by 2, and it ends in a 0. It's even. So there's lots of rules you can combine when you know a few. This one right. Beth knows the divisibility test for 3. Beth says that she can tell just by looking at this number, without doing any calculations at all in her head. This number, we see hundreds, thousands, millions, billions, trillions, billions, quintillions, extillions, so 999 septillion, 888 hextillion, 777 quintillion, 666 quadrillion, 555 trillion, 444 billion, 333 millions, 222,111. Just by looking at it, she knows it's divisible by 3. Why? Just by looking at it, without doing any sort of calculation. So, now the rule for 3, if the sum of all the digits is divisible by 3, you can divide by 3. So with it, she didn't do that. She didn't add all those digits up and 3 goes into it. If you do, it will. But how does she know without doing it? In each place item, from the septillion to the hextillion to the quintillion to the quadrillion to the trillion, you have 3 of a kind. So I have 3 of these 9. So this is going to be divisible by 3 because I can just factor out the 3. I have 3 8s. So they're going to add to something that 3 goes into. I have 3 7. I think that's going to be something that 3 would go into. So when I add all these up, 3 goes into everything. So 3 is going to go into the whole sum. So without actually adding them all together, I see bunches of factor out 3s. So 3 is going to go into that entire sum, no matter what. So since 3 divides the whole sum, it's divisible by 3. Because I have a whole bunch of groups of 3. Now, could you scramble it and find? Yeah, you can still find it. I have 3 9 somewhere in here, I have 3 8 somewhere, without actually doing the addition. Have I ever seen a number like this in a problem at any time? No. But it's just an example. All right, Magnet.